Bismillahirrahmanirrahim. So we will continue our discussion on the topics for mid one exam. Anyway, we will continue our revision. Okay, so we will see a problem now. You have a 12-volt battery and a resistance of 1 kilo ohm, and there is another resistance here which is again 1 kilo ohm. Okay, and here also there is one more 1 kilo ohm. Okay, and there are two diodes which are connected like this in series. Okay, and there is another 1 kilo ohm resistance, and you have another diodes which are given like this. Okay, and there is a diode which is connected like this. So okay, we can name the diodes D1, D2, D3, D4 and D5. Okay, now the question is to find the currents. Let's say this is I1, we have to find all these things, I1, I2, okay, and I3, next this is I4, okay, and this current I5, and this is I6. Okay, so this is the question. The question is to obtain I1, I2, I3, I4, I5 and I6. Okay, so this is the question. Okay. How much all these things? So we will solve this problem. So you can see here we have 6 diodes. So we will see which diodes are in on state and which diodes are in off state. Okay, so you can see here this is the positive of the battery. The positive of the battery is connected to the p type semiconductor of the diode D1. So D1 is in on state. Similarly, you can see this negative is connected to the n type of the n type semiconductor of the n side of the D2. So you can see that D2 is also on. Now we will see what about the D3. You can see here the D4. Regarding the D4, the current through the D4 actually the D4 is connected like the negative terminal of the battery is connected to the n type semiconductor. So D4 is in off state. Since D4 is in off state, the current through D3 also will be 0. So we can say our D3 will never become on because of the open circuit due to the off state of D4. Okay, so D3 also will be in off state. Now what about D5? So we will see that D5 is again it is in the on state. Okay, so we can redraw the circuit based on this. Redraw the circuit. So I can redraw the circuit. This is 1 kilo ohm and this is 12 volt battery. Okay, again we can see 1 kilo ohm resistance, and this is 1 kilo ohm. Okay, and this is something like this. Okay, now again 1 kilo ohm resistance, and you can see here the part which is having D3 and D4 which is open circuit. So the current through that means it is nothing but I5 which is equal to 0. Okay, now we have the diode D5. Okay, so that's it. Okay, we have the current I5 and here it is I4 and this is I3. Okay, and this is I2 and this is I1. Okay, so I forgot to write one more thing. That means write one thing. That means the practical, you have to assume the practical model for solving this. Assume practical model. Okay, practical model. So in a practical model we know that if the diode is in on state, the voltage drop across the diode is 0.7, and if it is in off state, the diode act as a open circuit. So we can see here we can mark all the voltages across the diodes. That means this is plus minus 0.7 volt. Okay, and this is again 0.7 volt, this is also 0.7 volt. Okay, and I think that's it. Okay, now let us consider this point A and this is B. So the voltage between A and B, that means VAB, you can see that there are two diodes. Because of these two diodes which are in on state and both are in series, so you have the voltage which is nothing but 0.7 plus 0.7, 0.7 plus 0.7, which is nothing but 1.4 volt. Okay, now uh, since it is 1.4 volt, okay, 1.4 volt. Now we will see the last part of the circuit, that means this part of the circuit, and we can see here the voltage between A and B is 1.4. So the voltage VAB is equal to 1.4, and I have a 1 kilo ohm resistance here. I am talking about this resistance, okay, 1 kilo ohm resistance, and I have the diode, and there is some current through the diode. We will mark it as I6. Okay, so since it is on, we have the voltage across this is 0.7, and you know that the voltage between the point A and B is again it is 1.4. so it can be easily concluded that this voltage will be 0.7, because you can see that the total voltage is 1.4. it is marked like that, like this. Okay, so we can also apply the Kirchhoff law. Okay, you can apply the Kirchhoff law, that means minus 1.4 plus the voltage across 1 kilo ohm resistance, then you can see here this is plus 0.7, this is equal to 0. That means the voltage across 1 kilo ohm resistance will be nothing but 0.7 volt. Okay, so this can be easily solved. So you can get this answer as 0.7 volt. Now we know that the voltage across the 1 kilo ohm resistance that we have shown here is nothing but 0.7, and the resistance is nothing but 1 kilo ohm. So the current I6 is nothing but voltage across 1 kilo ohm resistance divided by 1 kilo ohm. That means it is nothing but 0.7 divided by 1 kilo ohm, which is nothing but 0.7 milliampere. Okay, so this is the current. Okay, I hope this is clear to you. Similarly, we have one more thing I have to, so this current, that so we got I6 as 0.7 milliampere. Similarly, we know that the diode D3 and D4 are in off state, so we can see here our I5 equal to 0 ampere. Okay, this we have already seen. So this part of the circuit is solved. Now again I will draw the other part of the circuit, that means I will draw this part of the circuit. Okay, so we have a 12 volt battery, okay, and there is a 1 kilo ohm resistance, and we have the point A, and this is 1 kilo ohm resistance. Again this is the point B, I think it's point B, and we have again 1 kilo ohm resistance here, which is 1 kilo ohm resistance, and you know that the voltage between A and B is nothing but 1.4. This already we have seen from the previous session itself. Okay, here itself. Now VAB is 1.4, so you can find this current easily. What is that current? Actually it has been marked as I2. Okay, so it has been marked as I2. So I2 can be easily found out by VAB divided by 1 kilo ohm. It is nothing but 1.4 divided by 1 kilo ohm. So it is nothing but 1 milliampere. Okay, sorry, not 1 milliampere, 1.4 milliampere. Okay, so it is nothing but 1.4 milliampere. So we got I2. So we got I2 as 1.4 milliampere, and we have already I4 as we have already I6 as I6 as something like 0.7 milliampere. Okay, and we have already, this is I6 as 0.7 milliampere. Okay, next we can see here from the problem itself directly we can see this I4 and I6 both are nothing but the same current, because I5 equal to 0, because this guy, that means I5 equal to 0. So we know that I4 is equal to I6, so this is nothing but 0.7 milliampere. Okay, now we will see another part. You can see here I will take this node. Okay, I will take I will use a different color. So I will take this node. Okay, this is node A, you can say. So node A, I will consider the node A. So for node A, you can see here that there is some current which is I2 which is going here, and you know that this I2 is 1.4 milliampere. Okay, it is going down, and there is some resistance here and some other part of the circuit. Okay, now this is the node A. Now you know that the current, the other current is nothing but node A. Okay, I2 is going down. Now some current I3 is going down here. You can see this there is some current here which is this is nothing but I3. We have no idea about I3. Okay, similarly we will see we have another current, that means something, yeah, this is going here away from this node A, you can say. So this current is there. So this current, it is nothing but I4. We know I4 is nothing but 0.7 milliampere, but we have to find I2. So how we can find it? So before that I will draw the different other part of the circuit also, that's better. Okay, without that it is difficult to solve. So this is 1 kilo ohm, and this is 12 volt. Okay, and what about this? Okay, so since you can see here this is I1, this current is I1, so the current which is going back into the supply is also I1. Okay, now the voltage across this resistance we have already found out it as 1.4 volt. Okay, so I am going to take this loop here now. So I am going to take this loop here now. So what is this loop? I will start from here. You can see this is minus 1.4, sorry, not minus 1.4, it is nothing but minus 12 volt, minus 12, and the current is going like this. So it is plus here and minus here, so it is plus I1 into 1k. Okay, next you know that the voltage between A and B is already, it is nothing but 1.4 volt. Okay, because this is 0.7 and this is 0.7, so it is 1.4 volt. So plus 1.4 volt. Okay, then again the current is going back into the battery, negative terminal of the battery. You can see here again this is 1 kilo ohm, so it is plus I1 into 1 kilo ohm. So that's it, it is equal to 0. So you can see here minus 12 plus I1 into 2 kilo ohm plus 1.4 volt is equal to 0. So we can easily solve this equation, so that we will get I1 is nothing but 12 minus 1.4 divided by 2k, that means it is 10.6 volt divided by 2 kilo ohm, it is nothing but 5.3 milliampere. So you got it. So you got the current I2, so sorry, not I2, I1. So we got the current now. I1 is equal to 5.3 milliampere. Okay, so you know what is I1 and you know what is I2. I2 is already, it is 1.4 milliampere. So easily you can get this current. So what is that current? You can find that current. Okay, this current will be yeah, you can find this current. Let's say this current is id. Okay, sorry, something like you can put some name. Okay, ia you can say. So you can find the current ia. How much will be ia? Ia will be I1 is coming from here, and I2 is going down, so it is nothing but I1 minus I2. Okay, what is I1 minus I2? It is nothing but 5.3 milliampere minus 1.4 milliampere. Okay, so it is equal to 5 minus 1 is 4, and it is 3 point, how much it will be, 3.3, sorry, it will be 3.9. okay, so 3.9 milliampere. Okay, that's so IA is 3.9 milliampere. Now you know that I4 is equal to 0.7 milliampere. So you can easily find I3. How much will be I3? You can see here I3 will be equal to IA minus I4, which is equal to 3.9 milliampere minus 0.7 milliampere, so it will be equal to 3.2 milliampere. So you got all the answers. Okay, I will mark all the answers. This is I1, this is I2. Okay, then this part is showing I3, and this is showing I4. Okay, and from the previous page actually we have I5. Okay, and we have I6. Okay, so we got all the current. So this is one of the good problem anyway. So this kind of circuits you can expect for the exams. Okay, so we have seen 3 types of circuit like this. So this kind of circuit I will change the problem anyway, so you can expect this kind of circuits for the exams. Okay, now we will see another problem. There is an half wave rectifier. Okay, there is a half wave rectifier, something like this. Okay, now you have the turns ratio 20:2. Okay, and there is a diode and there is a filter. So this is a rectifier with a filter which is having 50 microfarad, and there is a load resistance which is shown here as RL, which is equal to 2.2 kilo ohm. Okay, that's it. Now you want to find the first part as VP secondary. So you can assume the practical model. Okay, now VP secondary. Second part of the question, VP out. Then the third part of the question is maximum current through RL. Okay, then the fourth part of the question is the VDC, or another name is V average. Okay, and E, the last part of the question, is the peak inverse voltage. Okay, so we will solve this problem now. So VP secondary, you know that, and also it is given that I will write it. It is 230 volt. Okay, 230 volt, and the frequency is given as 60 hertz. Okay, so if this 230 volt is given, it means that it is just the RMS value. Okay, so what will be the peak value? The peak value will be 230, you multiply with square root of 2, so it will give you the peak value. Now you can find VP secondary, this peak value at the secondary, VP secondary, by multiplying with the turns ratio 2/20. Okay, so if you multiply with the turns ratio, which is 2/20, I think you will get it as 32.52 volt. Okay, now VP out, is nothing but, you can find the Vp out by, Vp out is nothing but Vp secondary, and there is one diode. So this diode will consume actually 0.7 volt, so 0.7 volt. So this is nothing but 32.52 minus 0.7, which is 31.82 volt. Okay, now the maximum current through the RL, so this is nothing but the IF, which is maximum through the RL. It is nothing but the maximum output divided by the RL. Okay, so you will get it as 31.82 volt divided by 2.2 kilo ohm, which is equal to 14.46 milliampere. Okay, next we have VDC or V average. So what is the formula for this? VDC is given as not, it is not VP out by pi. Okay, it is because there is a capacitor filter. Since due to the filter there is a filter, due to this filter you know that VDC is equal to 1 minus 1 by 2 into F into RL into C. Okay, and this F is nothing but F out. And what is F out? F out is equal to F in half wave rectifier. In full wave rectifier it will be 2 times F. So but here this is a half wave rectifier, it will be 60 hertz. So it's into C into Vp out, you can see here. Okay, so this, if you substitute all the values, that means I will remove this part. So if you substitute all these values, you will get it as VDC is equal to 1 minus 1 by 2 into F is 60 into RL. What is RL? It is 2.2 kilo multiplied with C equal to 50 microfarad. Okay, then Vp out, you know Vp out is 31.82. So you will, I will write it here, into 31.82, you will get it as 29.401. okay, 40, this much volt. So I will write it in the next line. So this will be equal to 21.401 volt. Okay, so the next part of the question is nothing but the peak inverse voltage. So peak inverse voltage is equal to Vp secondary in half wave rectifier, because it is a half wave rectifier. So this is nothing but Vp secondary is 32.52 volt. Okay, that's it. So this is how to solve this type of problem. So next we will see a circuit which is a voltage limiter circuit. So you have a voltage limiter circuit, something like this is 1 kilo ohm, and you have a diode and a battery which is given like this. Okay, this is 3 volt and this is your V in. Okay, and the input V in is equal to, V in is given as a triangular wave which is something like this. Okay, this is 1 second here, this duration is also 1 second, this duration is also 1 second. Okay, everything is 1 second. That means if this point is 1 second, this will be 2 seconds, and this will be 3 seconds, and so on. And the maximum value is 8 volt, and this minimum value is -8 and -8. Okay, now you have to draw the output by assuming practical model for the diode. Okay, practical model for the diode. Okay, so I will show you have to take the output from here. So this is your V out, so this is your V out. Okay, and the V in is given, this is V in. Okay, now we will write the answer here. Okay, you see here I will first draw the input. So you have to draw the input first beautifully. Anyway, this is 8 volt and -8 volt. 8 volt and minus 8 volt. Okay, then this is V in. I have given you the procedure for drawing. So what is the first step? So you will first see which diode. First of all, you will see when the diode is on. So when the diode is on, what is the, so this is the first step. When D is on, V out, what is the V out? We will see what is the V out. So when V is on, when D is on, so this is the diode. So when the diode is on, you know that the current will be always flow from P to N. So this will be 0.7 volt, and this is minus and this is plus. So V out is equal to, you will first take here as plus 0.7 plus, you can see this is minus 3, so this is nothing but minus 2.3 volt. Okay, minus 2.3 volt. Now second part of this method is nothing but you have to draw the line at minus 2.3 volt. So you have somewhere here it is minus 2.3. okay, because this is 0 volt, so this is minus 2.3, so this is minus 2.3 volt. Okay, now we will consider the point with V in equal to 0. When V in is equal to 0, we will identify the situation of the diode. So when V in is equal to 0, I can redraw the circuit. For V in is equal to 0, when V in is equal to 0, I can redraw the circuit like this. Okay, I can redraw, because when V in is equal to 0, it's a short circuit. You can see here the diode negative is connected to minus. So what is the situation? You can see the n-type semiconductor is connected to the minus. That means the diode is forward bias, or the diode is in on state. Okay, so when V in is equal to 0, the diode is in on state. That means all the portion, you can see here the 0 is above our line. You can see our 0 is above our line. So all the portion which is above the line will be in on state. And when the diode is in on state, V out will be equal to, I told you, V out will be equal to minus 2.3 volt. Okay, and so when V in is equal to 0, the diode is in on state. So V out will be, because when diode is in on state, I told you it is minus 2.3 will be the output. So when diode is in on state, it will be minus 2.3. okay, so that's it. Now for all the voltage below the line, the diode will be in off state. That's what we have seen. We have already seen this. So the diode is in off state. So when the diode is in off state, V out will be equal to V in. So this is very, very important point. I don't know whether you can see this. Okay, when the diode is in off state, V out will be equal to V in. Okay, so so that's it. Now you will see here, I will draw these lines here, joining lines. You can see I want to join all these lines, extend all these lines to draw the output. Now you can see if I take any point, okay, I will choose a suitable color here. Now yeah, this is good. Now you can see here, if you consider all the points up to this here, all are above the line, so if it is above the line, you know that the diode is in on state. When the diode is in on state, the output will be minus 2.3. so I will draw here, this is minus 2.3 volt, so it will be minus 2.3. now at this point onwards, you can see from this point onwards, you can see that means this region, the diode is in off state. So when the diode is in off state, you can see here output will be equal to input. Okay, so here the diode is in off state, but here the diode is in on state. Okay. Next, again the diode is in on state because all these points are above the line. So we have again minus 2.3 volt, and this is output equal to input. Okay, that means the diode is in off state. So here the diode is in on state, and this will continue. So this is the output of this kind of clipper. Okay. So we will see one more problem, last one. Okay. 8, problem 8 as revision. Okay, we have a bridge rectifier, okay, with input of 115 volt VRMS and 60 hertz, okay, as the input frequency, and this is 20:2. This is the transformer part. Now I will draw the bridge rectifier with 4 diodes. You know that there are 4 diodes for the bridge rectifier, and the diodes will be connected as shown in the figure. Now this is connected here, and I will take the output from here, and this is the load resistance RL. So it is asked to find out many things. That means the maximum output voltage, that means Vp out. What is Vp out? The second part of the question, okay, the second part of the question, what is the average output voltage? VDC, or we can say V average, both are same. Okay, and the last part of the question is the peak inverse voltage. Okay, peak inverse voltage. So to find Vp out, we need to know first Vp secondary. So it is nothing but Vp secondary minus, there are 2 diodes will be on at a time. For example, this is D1, D2 and D3 and D4. So in bridge rectifier, 2 diodes will be on at simultaneously. That means the voltage drop across, the total voltage drop across 2 diodes is nothing but 1.4 volt. So Vp secondary minus 1.4 will be the output. And we know that what is Vp secondary? You know, this is RMS has been given. So first of all, I will convert the RMS into the maximum value, because we are talking about the maximum. So we need the maximum value, and after that I will multiply with the turns ratio. That means 20 is to, so 2, that means 2 over 20 after. So this is nothing but your Vp secondary. Now from this I will subtract 1.4. So I hope this part is clear to you. Okay, so it will be equal to you can say it is equal to 162.1, sorry, not 162, it is equal to 16.26 minus 1.4, which is equal to 14.86 volt. Okay, 14.86 volt. Now we have no filters, or we have no capacitor. That means we have no capacitor filter. So VDC is nothing but, or V average, we also say it is an average. Average means DC. Okay, that is the meaning usually used in electrical engineering. Okay, so that is a convention which is usually used in electrical engineering. There are a lot of reasons for that. Anyway, VDC is equal to 2 times Vp out over pi. It is because it is a full wave rectifier. It is a full wave rectifier. If it is a full wave rectifier, your this is full wave rectifier. So VDC is equal to 2 times Vp out over pi is the formula. So this is 2 into Vp out is 14.86 divided by pi. Okay, so you will get this answer as 9.46 volt. Okay, next we want to find out the Vp out, sorry, the peak inverse voltage. The peak inverse voltage is nothing but Vp out plus 0.7. The proof has been already given, so please see the lectures for the proof. The proof has been already discussed, okay, in the previous lectures. Okay, that is why I am not going to explain it here. So, it is nothing but 14.86 plus 0.7, it is nothing but 15.56 volt. So, I believe that all of you understood this problem. Okay. Thank you.